Question 9. Okay, so a circle. It's nice to finally get around to this question. A circle with centre C has equation x minus 2 squared plus 1 minus y plus 5 squared is 25. It was really nice that loads of people did this, even if you don't know where the question's going, and that's how it starts, then I think it's a pretty sensible thing to do, to write. From this we've got the centre is 2 minus 5, and the radius is 5. What have you got to lose? Even if that's not what the question's asking you for, it's pretty obvious information that we should get from that equation. So that's a great start. Actually, it turns out, in this question, you probably would get 2 of the 3 marks just for writing that.
Did you?
No. Never tell jokes. And then it says, show that no part of the circle lies above the x-axis. Well, that's it, isn't it? That having got this, you could do it with words, or you could draw a diagram to illustrate this. A nice way that quite a few people wrote this were by saying that if that's the centre at minus 5, then the highest point of the circle must be 2, 0, directly above that centre point, but 5 above it. So as radius is 5, the highest point would be 2, 0, because it's 5 above 2 minus 5, and that's just touching the x-axis, so it never goes above the x-axis. But as quite a few people did, I liked this way of answering it as well, which is, I've not drawn my axes very well, to draw your circle there. It doesn't really matter how good the circle is. There's the point 2, that's minus 5, the radius is 5, and so it shows that it never goes above it, and that would do. That's a nice way of illustrating the answer, isn't it? So that was it. So that should have been quite a nice 3 marks at the beginning of this question. Now, part 2. The point P has coordinates 6k and lies inside the circle. Find the set of possible values of k. We have done a few questions similar to this about whether points are inside or outside. If that point is inside the circle, then that means the distance from the centre to that point is less than 25, or less than root 25. So that means what we might do with this, the centre was 2 minus 5, this is the point 6k, so 6 minus 2 squared plus k plus 5 squared. It's inside the circle, so that is less than 25. It's inside the circle, so it's got to be a firm inequality, not an or equal to. It was definitely inside. That's just subbing it into the equation, and that would work just as well. What do we get here? This is 16 plus k squared plus 10k plus 25 less than 25, which altogether gives us k squared plus 10k plus 16 is less than 0, because the 25's cancel out. Does it factorise? I think it does. 2 and 8. Both positive, which gives us that. Which again gives us critical values. We're solving another quadratic inequality, aren't we? Critical values of minus 2 and minus 8. And again, we use our graph to help us with this, although I think we could probably get it from the diagram as well. But we use our graph to help us, because remember, if 6 is over there, then we're looking between those 2 points, so it must be between minus 2 and minus 8. So you can kind of get the conclusion from the diagram. Or we've just done a quadratic inequality that crosses at minus 8 and minus 2. We wanted to know when it was less than 0. Less than 0, down there. There it is, less than 0. So it's the in-between bit that we're after. So we're going to say that k is greater than minus 8 and less than minus 2. And that's all of our marks for that. It wasn't terribly well done, but it's quite a straightforward thing when you see it. Alternatives, well, I wouldn't really mind if you said you're going to treat it as if it is actually on the equation, find out the values of k where it's on the equation, and then turn it into an inequality at the end. So if you did this as that equals 25, got k equals minus 8 and minus 2, and then concluded it was between them, you'd still get all the marks. And you could have multiplied out the equation of the whole thing to start with, and then subbed in 6 and k, and that would have got the marks as well. It's a slightly longer way around of doing it. And the other thing that's worth pointing out, and I think at least one person did this, don't square out, you could not square out that bracket and keep it as a completing the square kind of problem. So you get k plus 5 on squared is less than 9, because 25 takes 16, and then you square root it, so k plus 5 is less than plus or minus 3, and then go from there. Minus 5 plus 3 is minus 2, and minus 5 minus 3 is minus 8. So you get the same critical values by completing the square method. Lots of ways you could have done it. Now, part 3, prove that the line 2y equals x does not meet the circle. Well, I think that, I don't know, I think that is kind of obvious to start with, is that just drawing a diagram of a circle and a line not meeting it does not prove that the line doesn't meet the circle. So you're not going to get the marks for that. I suppose you've got nothing to lose if you can't think of anything else to do. But that's not the way to do it. This is now simultaneous equations, isn't it? And what we do is we act as if the line and the circle do meet. And we need to show that we've got no answers if we act like that. So the line is x minus 2 squared plus y plus 5 squared equals 25. That's the line. That's the circle. And the line is, what was it, 2x equals y? No, x equals 2y equals x. There we go. So what we're going to do, our method for this, is to behave as if we expect them to intersect. And if they intersect, well, I think it's easier in this case to substitute for x, isn't it? Because x equals 2y. So let's replace x with 2y. That gives us 2y minus 2 squared plus y plus 5 squared is 25. Now what we're expecting to happen here is that this will give us a quadratic that doesn't just not factorise, it has no solutions at all. It's not that they have ones that you need to formulate, it's that it just breaks down, that something goes wrong with it. So here, if we multiply out this bracket, we'd have 4y squared minus 8y plus 4. If we multiply out this bracket, we would have y squared plus 10y plus 25. That lot is equal to 25. Now it's a quadratic, isn't it? Biggest power is 2 in there. We want to collect all the like terms together and see what we can do with it. We've got 4y squared and another y squared. We've got minus 8y plus 10y. And we've got 4 plus 25 minus 25. So we've got an equation that looks like that. Now let's be smart about this. We know where this is heading. This is heading for not having any real solutions. And the thing that we know about there being no real solutions is all to do with the discriminant, with b squared minus 4ac. So let's check what happens with b squared minus 4ac. If we work out b squared minus 4ac, that is b squared, so 2 squared, minus 4ac. And can we see we've got 4 take away 80? which is minus 76. And we know, it's on our poster, that if b squared minus 4ac is less than 0, that means there are no real roots. And if we find that there are no real roots in this equation, it means there are no solutions to it. It means there are no points where the line meets the curve.
Did you have to write that?
So you had to conclude that at the end.
Oh, see.
So a line does not meet the circle, and there we go. Okay, you had to draw some conclusion. Leaving it just as saying b squared minus 4ac is minus 76 isn't enough. You had to say it's less than 0, therefore no real roots.